I'm hoping you can all hear me. Those of you that have decided to join the class today, but that's fine. I've just shared my screen, and I'd appreciate it if, oh yes, Ms. Winter, thank you. I'd appreciate it if somebody could confirm if you can see my screen, but also if you can hear me just fine. Just
We can see everything and we can hear you.
Thank you, Mr. Notsa. All right. So anyways, in our most recent interaction, by the way, we have another class on Sunday, I believe, but more on that later. In our most recent interaction, we had started our discussion of, we're going through some example that was introduced during module number 2, if you remember. It's a real world problem, and the software that has actually been developed. So we gave a vague description of the problem, and we walked through the process, right? The typical process we'd have to go through for us to prepare a schedule. And we realized, right, as we were going through this example, that in fact, for us to create a schedule, a very crucial component that we need to make sure is in place is the so-called WBS, or the work breakdown structure. Without the work breakdown structure, it becomes incredibly difficult for you to create your timeline, your Gantt chart. And so the first starting point is you create your work breakdown structure, pretty trivial process, because it turns out that a typical software-centric project is associated with well-known phases. So your typical summary tasks will include generic things like planning stage, for instance. Generic things like those SDOC phases. Now, it's not all the time, right, that you will have your SDO phase having, you will have your Gantt chart having things like requirements engineering or something. And we don't expect you to have these things, maybe not, or something. Or software design, right? Software design, implementation, implementation, testing, and evolution or something. It turns out that depending on the software process model that you're leveraging, these things would be organized differently. And the classic example that I gave last time, and I do hope that everybody has taken time to think about what was discussed. We took the time to further break down these summary tasks that were identified. This is by no means comprehensive, by the way. This list of, I don't know how many tasks we had here, but this goes up to 38 tasks. It's not comprehensive here, but it gives us an idea of some of the things we have. A task that is tagged as project inception. There's a summary task that is tagged as risk management, in part because in this particular example, we decided to take a plan-driven development approach. There is a summary task called requirements engineering. We have software design, we have implementation, we have testing, and then we have evolution, which in this case we are tagging as handover. All right. The moral of the story here, right, or the point we're trying to put across is careful thinking has to go into the breakdown of the project. That's number one. Number two, before the breakdown of the project, the team working on this project needs to sit down and decide beforehand as to which software process model is going to be adopted or used, because that, in addition to a couple of other important factors, ultimately determines the structure of your Gantt chart, the activities that are going to be associated with your Gantt chart. Again, I want to draw everybody's attention to where is that here? I want to draw everybody's attention to these things that we're discussing, right? I don't know if you remember this here. These things that we're discussing. If we were to say we want to, I don't know if this is the one, but this is still agile. if we go to this example here, come on. Okay, it's not here. That's okay anyway. I thought the case study was that. But if we were to, there we go. If we were to go to our discussion of module number 2, right? The plan-driven development
Sir,
approach, right? Yes, sir.
we can't see the screen. Are you sharing or?
I am sharing. I think you're probably the only one because I know I can see it on my other device here. Is this affecting everybody, or it's just Mr. Arnold who is affected? Hello?
No, but personally, I'm able to see.
Okay, yeah. So you probably want to log in and log out and log back in or something, Mr. Arnold, sir. Right? So
Okay,
so in the example that I gave, yeah, in the example that I gave, I mean, we're looking at a plan-driven approach, but remember that if you decide to complement whatever strategy you're using with something like integration and configuration, then the details of what needs to go under implementation especially change. Right? Because as part of implementation, you would no longer have these things here, right? So if this was associated with integration and configuration, then what we would find ourselves doing here is incorporating these important issues associated with integration and configuration. Specifically, would perhaps include details to do with software discovery or something. All right, the software discovery process. We would then maybe also have some generic thing tied to a software evaluation or something, right? So these things would change, and it depends really on how you want to do this. Maybe what you may decide to do is, sure, you're going to implement, user interface. You have a service layer, you have the backend services that you have to implement, and then you have web services. Maybe as subtasks for these tasks, what you would then do is you'd have a dedicated kind of this is 5.1 here, a dedicated you'd have dedicated activities that would be tailored towards you working towards these things. Now, we know that, for instance, when you're dealing with implementation of a user interface, it's highly unlikely that you would find. What you would do is you probably come across CSS frameworks, for instance, right? Or UI frameworks. So things like React and Bootstrap and all those things. So what you would then do is you'd say, for the implementation of the user interface, you would have to go the route where you're looking for reusable components, right? Not full-fledged applications, right? So you'd say software discovery or something, but specifically discovery, you'd say this is UI frameworks or something like that, right? And then one of the other activity that we have here, right? When you have this is you'd have to have a process where you perhaps not perhaps actually you refine, right? So refinement. Yeah. So because when you find the UI framework, it's likely you'd have to compromise on some of the requirements. So you refine them further, right? After you refine them further, maybe you have an activity that is to do with, that speaks to the integration. Or you could call this system integration. You'd of course do the same thing for the service layer and the backend layer. In some instances, it may be the case that you would want to just leverage integration and configuration during the implementation of a specific subcomponent of the system. So perhaps your interest in using these reusable components is only tied to the user interface, right? For these other, for these other activities, you decide to take the more traditional approach. And also, the things that you'd be doing tied to rapid application development would be different as well. This is one of the reasons why I was making mention of the fact that typically people are making mention of things like, oh, we're going to use rapid application development, right? RAD. Well, what people would expect them to see are activities like requirements planning, construction, cut over. These must be explicitly included in the Gantt chart itself, right? Including these things that you iterate through, right? Where the iteration takes place. The same applies to the spiral model, right? If you're saying you're going to leverage a spiral model, then what we expect you to do is somewhere in the implementation, may not be exactly the way it's appearing right here, but somewhere in the, where is that thing here? Somewhere in the implementation, if we can just borrow this here. In here, you would have things like, well, I mean, of course, you'd have, well, not of course, but you'd have to derive this work breakdown. A starting point would be determining how many prototypes you aim to work towards, right? As you're developing this software, right? So maybe your not maybe actually your high-level tasks here could potentially be maybe you'd have inception and all that here, but you'd have something like this. It's just hypothetical here. You have a project inception, right, where you do the usual draft inception report, and the inception report will have details like, oh, we are going to use a spiral model as a software development model, that our process model that we will be using, right? Then we'll have the inception workshop. We'll come up with the inception report. Afterwards, once the work starts, what you would do is you tell your clients to say, the very first summary task is prototype 1. And then you have, under prototype 1, you'd have these different activities, right? Determine objectives. And then you have identify and resolve risks. And then you'd have development and testing. And then you'd have planning, next iteration. Do you understand this? And then you repeat this, because this is supposed to be iterative in nature, right? So you come back here, this would be your 3, and this would be your prototype 2. You do the same thing because your plan, your initial plan is to say you're going to iterate 3 times, so you come up with 3 prototypes. Yeah, you say 3 here, so it's like 4 here, and then you have prototype 3. Or in fact, if we were to kind of use the phrasing in this diagram here, would just say operational prototype. Right? And then obviously you wouldn't want to come up with a Gantt chart where you just say identify and resolve risks, right? Because it turns out that this process of identifying and resolving risks is code name for risk management. So in essence, this would be your 2.1, this would be your 2.2, but you'd have a 2.2.1, which would involve you identifying risks, right? So in essence, what you would be doing is this. I don't know where that thing is here, but if I can go back to, if I can draw attention to, if I can draw attention to the diagram I'm looking for here, the things you'd be doing are these. Compare and contrast these things here. Risk identification, risk analysis, right? And then you'd have risk planning. Oops, sorry about that. In here, you'd have risk planning, right? And then you'd have the risk monitoring activity or something, right? Again, this would be 2.2.2. This would be 2.2.3. Yeah, this would be a 2.2.4. And then this would be a 2.3, right? And then you proceed here. So you notice that there's quite a bit of thinking that needs to go into you coming up with a work breakdown structure. And again, very important, your work breakdown structure is in part informed by the software process model that you've adopted. Again, if we said we were going to use you do something funny, or fancy, you decide to do something fancy, you go to your you go to your clients and you tell them, oh, we are going to use Scrum. We're going to use an agile approach, but we're going to use Scrum. Well, okay, if you're going to use Scrum, then what we expect you to have in your Gantt chart are details associated with Scrum. Again, if we go to Scrum, if you remember our discussion of Scrum, we see that there's specific things that need to be done, right? Yeah. So maybe after inception here, you're going to say plan product backlog or something. All right. And well, it depends on how you're doing this here, but maybe you'd have your requirements. I don't know if you'd have your requirements. This needs a bit of careful thinking here, but you'd have your requirements engineering or something, because the initial set of requirements that you would identify here would feed into the product backlog, right? So let's say you have requirements engineering here, then as part of this process here, what you would say is you'd say, well, we are now going to have our 3, which is the iterations, is it? The sprints, right? So remember, you have to plan here, right? The duration of the sprints and all those things. So let's say you're going to loop maybe 5 times here. You'll have sprint 1 or something, all right? And then you'll have your sprint number 2 here as a summary task. Or let's say we're going to just loop 2 times here. What's also important here, all of these sprints here, by the way, you are conducting these important tasks, right? Yes? I don't know if you remember the activities that are here, but in addition to those development-centric, SDLC-centric activities, you must ensure that you include things like sprint review, sprint retrospective, right? Sprint reviews. You understand? There's a bit of testing and all those things. Very, very important. And of course, the beauty with an iterative approach like this is you just replicate the things that you have in sprint 1 as part of sprint number 2 here, right? If you want, you can be more detailed in terms of the specific modules that you're implementing, right? The specific things here. So your product backlog perhaps would be a list of features or something, right? Not the detailed activities, but this could be like features that you're implementing, right? Prioritize features, of course. And then obviously when you're specifying things like the duration and the start date and the end date, you must take into account the fact that sprint 2 only comes after sprint number 1, for instance. And things to do with testing and aspects of design, refining the requirements and implementation would be repeated in all of these different sprints here. Very, very important, right? Anyways, so we did that. And what I was hoping we could do today is to immediately, unless if there are any questions, to immediately segue into our discussion of yet another notation, project management notation or tool that we use to represent project schedules. Very common. It's called the activity network diagram. The key thing about an activity network diagram, which was discussed, I think, in the most recent interaction, is the fact that it's a dependency-based schedule. So in essence, one of the things you do in this notation is you represent dependencies that exist between the various tasks associated with the project being executed. So the screen grab here, the screenshot or the current slide essentially just showcases what's called an activity or node activity network diagram. All right. Very important information is being represented. We shall discuss all of these at length. But what's important is that by the end of, once you're done with the exercise of deriving your activity network diagram, you would have identified your critical path. In this particular slide, this would be the path represented by the red directed arrows. Yes. The other thing you would do is you identify things like the duration. right? So how long your project is going to take? 65 here. Days. I guess this is days. The other important things would be the float, the total float or slack associated with each task in the project. Very important information. Idea, this is the number of days for which a particular task can be delayed without compromising the total schedule of the project. So if, let's say, you have an activity called requirements elicitation, and the duration is maybe 10 days. If the slack is 2, then what that means is you can delay that activity by an additional 2 days in addition to the 10 days without compromising the total schedule, which is 65 days in this diagram. Yeah. But anyways, again, this is just going to be a very simple walkthrough in essence. What we're going to do is learn and understand exactly how we create an activity network diagram, use it to derive or to identify, to compute the duration, and to identify the so-called critical path. The path which comprises of tasks which must not be delayed if you do not want to compromise the project schedule or if you don't want the project to be delayed. So again, the activity network diagram is typically used to identify a critical path and also the duration. Some of the key elements associated with activity network diagram is the so-called earliest or early start date and the last date. And we'll look at all of these things in great detail here. Using that information, but including the duration, what you do is you can derive the total duration of the project, and of course the slack associated with each task linked to the project. To the right here, this block diagram is just showcasing the notation that we are going to use in this module or in this lecture as we are learning exactly how to come up with an activity network diagram. The reason why we emphasize on this is because depending on what sort of literature you are reading, a different notation may be used. Right? So the things you're going to see in here are going to be represented, or at least the nodes in your activity network would be represented by specifying the name of the activity or the code of the activity, right? Which will almost always be the middle cell here. The early start, right? It's going to be this cell to the far left. The duration of that task, the early finish, the late start, the slack, and the last finish. What is also important to mention here is, and I think you've already figured this out, it's incredibly difficult for you. In fact, it's virtually impossible for you to come up with an activity network diagram without first of all coming up with a corresponding work breakdown structure. So the work breakdown structure is used as input to your activity network diagram. And this makes sense, right? Because we are saying that this schedule is actually a dependency-based schedule. In essence, one of the key characteristics associated with this notation is you model the dependencies that exist between your tasks. We're going to use this example from your recommended text, Yam Somerville. I believe it's the same thing that is in edition number 10, which we are following here. This is a very simplistic project we are looking at as an example here. Simplistic because you notice that there are no deliverables. I think this was mentioned. And perhaps there are certain things that may not make sense here, but we're just using it as an example nonetheless, right? Another point to note here is that at this point, the other thing we are assuming is that you have already identified the resources that are attached to these tasks. So in essence, what we are using is not the effort, but the duration, right? So this cell here, the top row, middle column, it's called duration here. This duration is linked to how long you think the task is going to take relative to the resources that have been allocated to this particular task or activity. Okay, so it turns out, right? I mean, at the beginning, when you're doing this for the first time, it's usually a good idea to follow or to use a more structured approach. And what I've personally found, and I believe this is probably documented elsewhere in existing literature, is following a series of steps. I'm not sure if these are standard steps here, but if we've missed out something, it's probably one or two things. If we've included things here, it's probably one or two things as well. So you start off by coming up with a dependency tree. I don't know what's happening here. There's a meeting. You come up with a dependency tree, right? You identify the dependencies that exist between the tasks associated with the project using your work breakdown structure, of course. If you remember from your work breakdown structure, one of the things you do is you identify the dependencies, right, that exist. Creating a dependency is quite easy because you have a work breakdown structure. Again, a reminder that we're using the so-called activity on node approach, all right? You first of all start with the tasks that have no dependencies. There will almost always be a task that has no dependency. It's not possible for you to have a work breakdown structure where all the tasks have a dependency. This is not possible. There always has to be something you start with, right? So in this example, we are saying is we're going to start with the tasks that have no dependencies. So we write or we draw the nodes, or we represent the nodes that have no associated dependencies. In this case, is T1, T2, T4. And we're going to go through these in order, starting with T1. So we see that we have T1. Yeah. The next node that has no dependency is T2. So we represent T2 at the same level as T1. The next node that has no dependency is T4. But at this point, really, I think in this example, what we're doing is we're just going through the task in the order that they appear in the work breakdown structure, which is okay, I guess. So in essence, we're going to go through T1, T2, T3, all the way up to T12 ideally, right? So T1, T2 have no dependencies, but we see that T3 has a dependency. It's dependent on T1, right? We have to model that dependency by using that directed arrow, right? In essence, the tip or the base of the arrow signifies the task on which the following task is dependent on. So in this particular case, we see that T3 has a dependence on T1. You cannot perform T3 without performing T1, right? So you have this directed arrow to model the dependency. It's similar to how we model the dependency in a Gantt chart, if you remember, right? I want to draw attention to this diagram. Hope it's here. The directed arrow signals this dependency, if you remember this. Same approach here. Only this time around here, there's nothing like, oh, the y-axis is your tasks and your x-axis is the time. No, right? We're not creating this notation or this model here on an x-y axis, right? It's somewhere in space here, right? With no really predefined axis that we're using. But anyway, so we have your T3 there. We see that T4 has no dependency, right? So we represent our T4 with no dependency, so no directed arrow here, to or from T4. And then we see that T5 is dependent on T2 and T4. The way we model this is we need to draw arrows from both T2 and T4 pointing to T5. So there'll be an arrow that will come from T2. It will originate from T2 and terminate on T5. There'll be another arrow that will originate from T4 and terminate on T5, like this. So an arrow that originates from T2 terminates on T5, originates on T4, terminates on T5. Dependency. T6 is dependent on T1 and T2. We shall have an arrow that originates from T1, terminates on T6, originates on T2, terminates on T6. T1 to T6, T1 to T6, T2 to T6. Now, at this point, I just wanted to mention that there's no prescription on where these boxes are supposed to be. We could just as well have decided to have T6 onto the left here or something, or somewhere at the top. But it's always a good idea to make sure that these arrows are not tangled, right? You shouldn't have them crisscrossing. Otherwise, you end up confusing yourself. But anyways, the next task is T7. We see that T7 has a dependence on T1, meaning that we should have an arrow that originates from T1 and terminates on T7. T1 terminates on T7. T8 has a dependence on T4, so we have an arrow from T4 to T8, T4 to T8. T9 has a dependence on T3 and T6, so we should have arrows originating from T3 to T9, sorry, and T6, I believe it is, to T9, right? T6 to T9, T3 to T9. T10 has a dependence on T7 and T8, so arrow from T7 to T10, arrow from T8 to T10. T7, T10, T8, T10. In some instances, it's virtually impossible for you to avoid arrows crisscrossing. This is one such case, but hopefully this won't be confusing. And then T11 has a dependence on T9, so we should have an arrow that originates from T9 and terminates on T11, T9 to T11. And then finally, we see that T12 has a dependence on T10 and T11. So we have an arrow originating from T10 terminating on T12, from T11 terminating on T12 as well. 10 to 12, 11 to 12. At this point, you begin to realize that it is important for you to come up with a realistic coding system. If I was to go back to the examples I was giving in this work breakdown structure, you'll notice that just simply having the IDs for these tasks, simply using these numbers like, oh, this is a 1 and this is 1.2 is perhaps not a good idea. Maybe what might be desirable for you is to come up with a column called task code or something, where you say, well, this is going to be concatenate T and this. So this is just going to be a concatenation of the letter T and the code that you're using, really, right? So you just use the formula here from Mr. Morimu's course and have this. Right? This is probably a good idea. This way, all you do is you're referring your breakdown structure in such a way that you come here, oh, I want to model T1. Okay, I write T1.1, T1.2, T1.1.1 or something. All right. Something else I wanted to mention is you immediately realize that the example here is too simplistic. In a real world setting, if you're using an activity, if you're coming up with an activity network diagram, it's obviously going to have quite a number of nodes. Like if you look at this example here, it's not by all means comprehensive here, but would have a total of 38 nodes, not the 12 nodes we have here. All right. I guess the other important thing here is that maybe, not maybe actually, we'll be using a 2 for you to do this. But anyways, that's fine. It's neither here nor there. So once we create this dependency tree, which is stage number 1, if you remember, we are following through with these 5 steps here, right? What we do is, in preparation to actually go through the next step, which is the forward pass, what we do is we need to specify the other important information associated with the project, which is the durations. Because when you come up with a work breakdown structure, one of the things you'd already have here is the duration. And I guess the start date implicitly, right? Which is always 0. Day 0 is when you're starting, right? So all we do is for each of these 12 nodes, essentially, we are going to specify the dependencies in the appropriate cell. If we're to draw attention to the notation that we are using, the duration is in the middle cell in the first row, or the middle column in the first cell, right? So 1, 2, right? Second column here. Okay. Anyways, I don't know if we are done here. We are done here. So once we specify the durations, we can then go through step number 2, which is computing the so-called forward pass. All right. So for us, incidentally, the forward pass, you go through the forward pass in preparation for you to identify the critical path. Remember, one of the reasons why you're using an activity network diagram is obviously you want to model the dependencies. Dependencies are much easier perceived when visualized rather than looking at a table like this, right? So this is somewhat more helpful. But also what we want to do is want to use this, this tool or this notation to derive the duration and identify the critical path. For us to do that, we need to first of all go through a so-called forward pass. So with the forward pass, you start with nodes that have no dependencies, because it turns out that I want to draw attention to this notation we're using. It turns out that and I wonder what the best way, the early start is going to be 0 for nodes that have no dependencies. The earliest you can start, the earliest you can start a task that has no dependency is on the very first day of the project, which is why we're saying the early start date is going to be day 0 for all tasks that have no dependencies. Okay. So you will notice that again, we'll go through this here. Forward pass, T1 has no dependency, so early start is 0. In addition to what I want to do here is, what I'm going to do is, I'm going to apologize here. I think it's going to be a lot easier if I context switch from here. Beautiful. And I can close this, I guess. Okay, so we see here that as part of the second step, the forward pass, we first of all start with nodes or tasks that have no dependencies. T1 has no dependency, which is why the early start date is 0. Once you identify the early start date or start time, in this case, you can derive the early finish. Right? All you do is you add the duration, the total duration of the task to the early start. So in this case, it's 0 plus 10, which gives us 10. Okay, we go to T2 because T2 has no dependency. So the early start is 0. The duration has already you've already come up with the duration as part of the planning process. You figured out that it's going to take you 15 days. By the way, this duration is in 15 days. The early finish is going to be 15 plus 0, which is 15. We go to T3. Because T3 has a dependency, see this directed arrow, it has a dependency on T1. The earliest we can start T3 is the earliest we can finish T1. So in essence, we just move the early finish date for T1 to be the early start for T3, moving 10 there. And then we compute the early finish by adding 10 to 15. We have it 25. We go to T4 because T4 has no dependency, right? See, no directed arrows originating from anywhere and terminating in T4. The early start is 0. The duration has been predefined as part of the planning process. You've identified the duration of you've allocated the total time it will take to accomplish this task as part of the planning process. So it's 10. And then the early finish is going to be 10 plus 0, which is 10. You notice here that this is interesting. T5 has a dependency on T2 and T4. At this point, you are faced with a challenge of, because the earliest we can finish these two tasks is different. It's 15 for T2, it's 10 for T4. The challenge is identifying what sort of early start you're going to use. Well, it turns out that it makes sense for you to use the maximum of the two, because the earliest you can start T5 is the most time it would take in between these two tasks where T5 is dependent on. So we are saying that T5 has a dependence on T2 and T4, all right? In the event that you finish T4, which takes 10 days, you still can't start T5 because you'd still be executing T2, which takes 15 days, which is why we're picking the maximum, which is 15 here. And then we do the usual stuff here. We add, 15 to 10, and then we continue with these other tasks, right? I don't think I have to go through all of these tasks, but maybe I can go through these. I don't know. We come to T6. We see that T6 has a dependency on T1 and T2. We get the maximum early finish between T1 and T2. What's the maximum between 10 and 15? It's 15. We move the 15 to be the early start for T6. We go to T7. T7 only has a dependence on T1, so we move the 10 there. And then we add the 10 to the 20, we get 30. We move to T8. T8 only has a dependence on T4, so we move the 10 to be the early start for T8. We move to T9. T9 has a dependence on T3 and T6. The maximum between 20 and 25 is 25, so move 25 to be the early start for T9. We go to T10. T10 has a dependence on T7 and T8. We get the maximum between 30 and 35, which is 35. Then we go to T11. T11 only has a dependence on T9, so we get the 40 here to be the early start for T11. And then finally, we go to T12, which has a dependence on T10 and T11. We get the maximum early finish for T10 and T11. As luck would have it, it's the same amount, which is 50, so we just move the 50 there. And then we add the 50 to the 10, right? It turns out that once you're done with processing the last task, this value here is your planned project duration, which in this case is like 60 days or something. All right. I think this is like a trivial thing, really. The point I wanted to bring your attention to is the mistakes I've noticed a number of students make. I don't know where this is coming from. You'll find in your proposal in 4014, for instance, you're told to come up with an activity network diagram. And what we see is you have these codes, T1, T2, but there's no mapping, right? You don't have a corresponding work breakdown structure that tells us what T1 is, what T2 is, right? I don't know where that is coming from. I don't know if any thoughts or questions about this, but very trivial process, which perhaps should be taught in grade 11. I don't know if they teach this in grade 11. Any thoughts or questions about this? No. Okay. Anyway, so at this point, in as much as we figured out the duration, we still haven't identified the critical path, right? And it turns out that the backward pass, the process of going through the backward pass, enables us to determine the critical path. Yes, Mr. Arnold, sir.
Oh yeah, it's me, Twambosa. We are using one device. So I have a question on. Yes, I have a question on the same thing we are from doing.
Which same thing is that?
Yes,
The diagram,
the
the
diagram
network
that.
Okay. Yes.
Yes, maybe you go back on the diagram, so just a bit. So I wanted to find out like how you are putting the numbers on the middle column on
the
top
ones
of.
on between is.
The numbers on the middle column?
Yes, like for example, where there's T1, then the number on top 10, like how did it come about?
Well, so when we remember, we started off by creating the process is simple. Here's the thing. Please, what you must do for this to make sense is all of you in your next meeting, come up with a comprehensive work breakdown structure and then draw a dependency tree from there. But the process we said is such that you, first of all, we've said you create a dependency tree, right, or structure as step one. Step two is, I'll call this add task durations to dependency tree or structure. So we did this as part of number 2, by the way. When we came up with this dependency tree, what I said was that you go back to work breakdown structure and you use these durations you'd have identified. You see T1 has a duration of 10, T2, 15, T3, 15, T4, 10, T12, 10. So for T1, we would come here and put 10 here. For T2, it's 15. T3, 15. You see where these are the durations in your work breakdown structure anyway, is what I'm saying. Does that answer your question?
Yes, sir, it's clear now.
Yeah, but also what you want to do is when you're doing this for the first time, it may seem like it's confusing or something, which is why I was trying to see if I could context switch to here, right? Where this notation, activity on node notation we're using is such that your activity is in the middle, the duration is right on top here. So in essence, when you're coming up with an activity network diagram, the things that you derive are early start, early finish, late start, late finish, and slack. These other things are coming from the work breakdown structure. Activities are coming from the work breakdown structure in this column called task. T1, T2, all the way up to T12. The durations are coming from your work breakdown structure. In this work breakdown structure we're using, the tabular notation, it's column 3, which is the duration in days. Of course, the dependencies are also coming from work breakdown structure, which is why we're able to create that dependency tree, if that makes sense. Listen, I'm preparing for another meeting. What I'm going to do is I wanted us to finish this, but we have a class on Sunday anyway. So is it Sunday or Monday or Saturday? We can, yes, there's a question from Isaac. I don't know if it's Sunday or Monday.
Yes, sir.
Sunday, sir.
Yes.
Going
Okay.
back to the, yes, I have a question concerning the activity network diagram, the first one.
Yeah.
Maybe you can just go back to the diagram, sir.
Oh yes, of course. By the way, I don't forget this. If it's on Sunday, then it's the 23rd. Can we maintain 18 hours? What? Or 17 hours?
18
On
is
Sunday.
okay. 18
is
is
okay.
okay. Sir.
17 or 18 is
Yeah, I
okay. Anything.
Yeah, I guess people are going to the prayers or something, right? In the mountains. That's fine. So there's a question from Isaac.
Yes, sir.
He's saying I go back to this thing here.
Yes. On the dependencies column, I'm seeing something like, I don't know if it's
Yes.
milestone 1, milestone 3 or something. Does it
Well,
mean
it's not
like
really a dependency. What we are no, so well, it means that it's two things here. What we mean here is that task T3 has a dependency not just on the task T1, but also on milestone 1. Now, the way we're representing this is done for brevity. What we're saying is that milestone 1 is attained after completing task 1, if that makes sense. So, in essence, we can change the representation if that is not very clear. But in essence, what we're saying is that notation tools here. In essence, what we're saying is when we have T1, let's say this is T1. We have T1 like that. We are saying that we'll execute T1 at the end of T1, right after T1. It doesn't have to be right after T1, but we'll have milestone 1. And this milestone 1 here, that diamond thing, will be right after T1 like this. But yeah, like this. So you only attain milestone 1 at the end of T1. And then when we have this T3, which has a dependence on T1 and milestone 1, somewhere here, maybe we'll have T2. I'm using my touchpad here. Do forgive me. And then we have T3. So for T3, what we're saying is that T3 will have a directed arrow. So this is your T3, like this. T3 has a directed arrow that comes from here, like this. But also from here, like this. Does this make sense now?
Yes, sir.
So there are two dependencies. Yeah. So there are two dependencies. This is what this means here. Yeah, anyway. So another example is if you look at T5, right? T5 has a dependence on 3 things, T2, T4, and M3. But if you look at this notation, what we're saying is M3 is associated with, it's a milestone that is linked to T4, essentially. If that makes sense. But anyway, are there any other questions or thoughts about this? If not, I suppose I don't know what's happening here, but if not, I'll see you on Sunday at 18 hours, it says here. Thank you very much. And enjoy your long weekend or your weekend.
Sir,
Thank you, sir. Enjoy your weekend as well. Good night.
sir.
Thank you.
Yes,
There's
sir.
a yes, Mr. Arnold, sir.
Oh, it's me, sir, Twambo.
Oh, yes, Mr. Thompson.
Yes. Just away from what we have been discussing, like I had a question. No, I have a question actually, two of them.
Yes.
Yeah, concerning
Yes.
the proposal. Yes. So,
Yes.
for example, if we on the types of models that, for example, if we choose integration and configuration model, there are three types of reusable components, like the web collection, like the standalone applications. Are we also supposed to include those on the proposal, or we have to
Yes.
choose one or
Yes.
something?
No, you have to include what you're including are a series of activities you're going to go through.
Okay.
So you're saying if you're planning to reuse an already existing piece of software and also components, those things have to appear. Because the reason they have to appear is you will spend time looking for those things first, but also evaluating those things. All right.
Okay.
So they have
Yes.
to appear. Can I ask that you push the other question to? I'm late here, but maybe we can
Oh,
answer
all right.
your question. What was the other question?
No,
Well,
like
maybe
I
we
just
can
wanted
address
to
it.
okay, I just wanted to find out, like, on data correction methods, can we use more than one method to correct data in a proposal research? Proposal.
Yes. You can.
Okay.
You'll soon see during our discussion of requirements engineering, which is right after this module, that the recommendation is always that you use an assortment of data collection methods.
Oh, all right.
Yeah. So yes.
All
Thank
right.
you very much,
Thank you.
everybody, and see you after tomorrow.
All right.